Hi, we are Group 9, Lab Section A07. My name is Martin Romero, and my partner's name is Shia Bruhis. We did our Engineering 6 final project on quantum well and heat diffusion.
The first part of the project was the quantum well. Task 2 asked the user to select the disintegration number of a nth variable within a range of interest. If the user simply hits enter without selecting a value, then the default value of 1000 will be set as capital N. Task 3 initiates the variable con to contain the string yes. It will continue a through loop while the con variable is equal to yes. The user then inputs a value for its not. If the user hits enter without selecting a value for its not, then the default value of 20 will be inputted. Task 4 asks the user the number of solutions to be stored in the variable solutions. If the user hits enter without entering a number, then the value of 5 will be used as the number of solutions. If the number of solutions entered is larger than the existing solutions, it will set the solutions equal
In
to
task
the
5, the
maximum
user
value.
inputs a precision requirement that the solution must be within for it to be accounted for. Then we create two arrays, one that will hold the answer and one that will hold the number of solutions that the user inputted. We start our counter at 2 and we initialize the first index of each array to be the first index of the X array, which is 0. Then we go through a for loop that checks every value of X that we discretized and sees if the difference between the two functions is less than the precision. If it is, then it checks against the previous value, the difference in the previous value, and whichever one is, it checks between the previous value and it checks if it's the same solution as the previous value, and if it is, then it replaces it. Notice the k-1, otherwise it puts it in the next spot in the k. Now the reason I have user answer and just answer is because user answer will fill the array with the number of solutions that the user asked for, while answer will store all of the solutions. Then the program asks it says that if the precision requirement was too small and there weren't enough sampling points, then it warns the user. Then it plots the graphs, and then it asks the user whether it would like to find an mth interval, which just means that which specific solution it would like to find. And it can be outside of the solutions range that the user inputted, but it must be within the inputted value of x over pi, because that's the total number of periods that cotangent has. Then it asks the user if it would like to continue using the program. If they say yes, it will do another run through. If no, or any other thing, it will exit.
Part 2 of the project was heat diffusion.
At the beginning, two global variables are created, one for the bounds and one for the discretization. Then in task U, based on the givens in the assignment sheet, we calculated A and K. Then in task 3, the user inputs where the point source heater is located, and then it asks exactly what time the user wants to calculate the temperature, and then the temperature equation is given, and the reason we have K equals 10,000 and hot equals 1 times 10 to the 10th is because our graph needed to be scaled so that it would be able to be seen on the plot. Then we created an array of times from 0 to t, the inputted t, and discretization from -400 to 400. and then we set n and m equal to the length of those two arrays. And then we had 4 for loops to go through each specific value in each permutation of combinations, and we set in the x array, in the y array, in the z array, and in the time array that specific value, and set it equal to the discretizations, either posi or positive or posi-t. And then for each specific 4 x, y, z, t's, we plug them into the temp equation to get a specific value at that coordinate and store it into the temp's 4-dimensional array. Then we plotted the mesh when z equals 0. Then we plotted the contour. And lastly, we created a little movie from time t equals 0 to time t equals t with a delay of half a second, and it shows the progression of heat throughout the room.